Hi, it's Gadget UK here again. This time something a little bit different and interesting to me at least. An Amiga 2000 power supply, faulty for spares or repair. Yeah, so we've got the part number there, 380708-01. Power supply Amiga 2000, 110 to 220 volts, 220 watts, so it must be switchable. It's got the IEC lead there, but there's nothing region specific to that, is there? So normally you'd have like a switch or some jumpers or something on the board to switch between the 110 to 220 volts. But in the UK here we used to use 240 volts, and it's nearer to 230 or 250, depending on where you are, I think. It could be wrong. I just remember a ballpark of between, say, 235, 250 volts in the UK. So does that work with 240 volts? You know, because ours is supposed to be 240 volts for the people that don't realise that. So this is different to mine. It's the one that's got like a round mesh can to the back of it, which is better for air circulation, I guess. I think mine's just got slots, some slots, I don't know, honestly can't remember. Yeah, so the connector there looks good. All the wires are intact. We've got the Molex ones here, you know, the standard ones you get for hard drives and things, or floppy drives if you've got one of those, you know, 5 1/4 if you've got the PC card fitted. They've got these dodgy things here. I hate these on the 2000. The problem with these is you can accidentally get these on the wrong way and feed you, you know, get your 5 and your 12 the wrong way around. But I think the side here that's got like a bit of an indent is the side that goes with the connector. Yeah, I need to check that before I disintegrate my floppy drive, which I did recently actually on a 500 Kilda. It was a Rev 3 one where it's got the pins stuck up with no plastic hood on it, so you can get it either way around. And I measured it in advance and assumed the red was 5 volts, and it's not. The brown was 5 volts on the 500 there. So yeah, I think we'll start by just powering this up and see what happens. Does the fan spin? These boards may need load before you get a sensible voltage there. I honestly can't remember. There might even be a sense pin on here. It's been a while since I looked at the pin out on the 2000 motherboard there for the power supply. So you can see there's a thing missing here. You know, you'd have the opposite way around here. You've got a female IEC, you know, kettle lead type thing, the sort of thing you use with a PC power supply. Very common, that connector. But often below it, as you'll see in many PC power supplies, there's the male one down here, so you can put a female to male, connect your monitor up and then power both on at the same time. So I'm not sure if that ever had anything there. I need to look around the back of my 2000 because I can't honestly remember whether it's got the other one there or not, and whether someone's took that out. But it kind of looks untouched. You know, the marks on the screws here, you can see that thread lock stuff. They stick it on there, and it's like it's in exactly the right spot. So I don't think anyone's been in this. And if I look through the little holes here, you won't be able to see, but it's full of dust. So I just think that never had one. And I think that the back of the 2000 probably, you know, the plate that comes around here or something just like masks that off. Now I really should get the vacuum onto this first. Alright, now we've done that, let's just try and plug it in. You should always test, in fact let's do that as well. When you're working on a power supply of unknown origin, just check you've got a connection between your earth and your can here. For all we know, someone's joined up the live mains to the can or something. It's not something you need to worry about with plastic covered PSUs, but yeah, so the earth pin is definitely connected. Let's just check between live and neutral, nothing there. There's no external fuse or anything on that, but now, you know, knowing that this is earthed, switching it on and holding my hand there, at least we know we're not going to connect mains up to this. Yeah, and if we did, it's joined straight to earth, it'll trip the mains. So let's just switch it on, see what happens. Tick, 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 tick. Can you hear that? Now that might be because there's no load. This is the thing. It's ticking even faster now it's off. So I'm going to check the pin out here just to make sure there's no sense pin or something like that. And then I think what I'll do is I'll just calculate a power load with a resistor, wire wound resistor, and we'll wire up here between ground and 5 volts, because I think that's the only thing it's going to need to draw a bit of power maybe. and just see if we can stimulate anything other than ticking. I don't know, I'm kind of thinking it might be a startup problem or something with this, or it may just be cutting out because something's wrong with the switching. One of the voltages might be low or high. Right, so I've wedged in these two resistors. They're in series here. I'll just append this central connection up. We've got one 4R7 there and another 4R7 in series. Two almost 5 ohm resistors in series. Because we've got 5 volts using Ohm's law, I'll show you that in a minute, and I've shown it before, we can calculate we're going to be drawing about half an amp. It's going between one of the ground connections and one of the 5 volt connections, and they're just pushed into the points there. Let's just see if we get any difference in behaviour. Still ticking. Yeah, so we do have some sort of startup problem, because I don't think there's a sense connection or anything. I did have a look at the pin out. There's a user 5 volt pin. I'm not sure what that is. I don't think I've ever queried or looked at what that is. So I think the next thing we'll do is just carefully disconnect that, and yeah, just get the screws out that hold this metal lid on top. Right, just carefully pull that off. Oof, yeah, it's a bit fluffy in there, look. Ugh. Oh, that's awful. Yeah, so I've just raised you up there. Look at the state of the inside of that. Oh, it's really fluffy and dusty. So I'm just going to do the same thing, vacuum that as best as I can. And when you've got that sort of situation, a brush may help. It's going to be a bit fiddly to work on this because you've got this giant heatsink here, and of course it could be a transformer failure or something, but I'm thinking it's probably just going to need a recap, and it could be something like a startup resistor or something or a cap or something on here that's causing the issue. Got some wire wound resistors down there. I think we really need to get this out of the shell, don't we? Oh, it's going to make a mess, this, isn't it? And I'm not sure, but is that fan riveted in? Yes, it is. Oh, that is really annoying. Why did they rivet these in? Cost cutting, I guess. Anyway, I've got screws that I could use to replace that, and we might want to replace that fan anyway. Maybe fit something a bit more silent. But what we may have to do is, I don't know, cut the wires or something, because I don't think there's a connector. It looks like they're soldered straight on, maybe. Alright, so you know what, I think before I do anything else, I'm just going to test a bit of warm air, not hot air, warm air, on a couple of the small caps around here, and then try and see if it comes on, just to see, is it a startup cap thing? Just see, is that going to make any difference whatsoever? Probably not. It's always interesting to see if things like that have any effect. So yeah, we're going to have to tear this down, I think, further, which I wasn't worried too much in advance, because I was thinking I'll just disconnect everything. Well, it's these rivets here that are annoying me. So I think what we'll probably have to do is disconnect what we can. Are those screwed on? No, those are riveted as well. Oh God, no wonder someone sold this on. I guess they really didn't want you to service these, did they? Anyway, I think what I'll probably do is cut some of the clips around here too. Well, I'll do that last, but slide this out as we've unscrewed the board, try and lift the board out at an angle, just see if we can have a look on the underside. So I've got the two screws at the front out, one in the corner up there, and there's nothing in that corner. I had to just pull the wires there under the fan in order that the board would just slide forwards a little bit. But you can just see down here now, I'm filming this for my benefit more than anything. We've got an empty spade, then the neutral, an empty spade, and then a wire, yeah, the black wire, which is probably the live, I would think. So let's just carefully pull this spade off so it goes on the second one. That's good, that is detachable. And then the back one, yeah, it's the back one, that's right. That's the back one. So we've been able to connect the mains thing there. So that's a relief, that was easy. So it's just going to be the fan, isn't it? And you can see this thing here, they have just lifted like that. But right now, look, we're stuck because of the fan wires. So I think we're going to need to cut these here. We can always stick new cable ties on later. So let's just carefully cut the cable thing there. Just see if I can work out where these are going. So yeah, we've got another one here. Let's cut that. Being careful not to trim the wires. Things are crimped. There we go. They push right into the wires. So here we go. That'll just give us some extended length on the front wire here, the red and blue. God, that wire's stiff. Yeah, and that should allow us maybe to pull it further out now. Hey, there we go. Oh, phew. So yeah, maybe I was well, I was talking rubbish when I said maybe they didn't want you to service it. It is a lot more serviceable than I thought in that respect. So yeah, we got lots of fluff to get out of there, and now we've got better access to the board. I can obviously get the hoover onto this again. Look at this, it's horrible. The print down here is gone, look, I don't know what's happened there. Let's just have a quick look on the underside. So yeah, this is where you might want to be careful, because this capacitors here may hold a charge. And you could get a shock. Look at the state of that there. You see that? Look how long that is. Yeah, I've zoomed in on that so you can see, look how long that is. That's nuts, that's been touching that thing on the inside there. I don't think that's the fault on that, look how long that is. That's crazy as well. Yeah, anyway, I will inspect with magnification to just see if there's any dry joints there. But other than flux, and obviously those two long connections, it's yeah, it kind of looks alright. So, nothing obvious from an inspection, but I think the next thing we're going to do here is desolder the semiconductors. I'm just trying to flip this over if I can. Everything that joins the heat-sinked bit here to the PCB, I'm just going to desolder those, try and get that heatsink off. There is a bit of a black connection there, can you see that? Yeah, it's just a bit blacky, so I'm not sure if something there's failed or what, but there's no dry joints or anything. That may be the main switching transistor, I don't know. Yeah, so single-sided PCBs, so these things should hopefully come off pretty easily. I'm trying not to touch the caps with my wrist there. I haven't measured those, but there is a bleed resistor over them, I think. Sorry, the camcorder cut out there, battery went flat. I really need a new camcorder, I think, at some point. You'll notice that you can hear this thing going when it zooms sometimes in here. So the gears are a bit knackered on it, the battery's knackered on it, there's a couple of blobs inside on the lens, you know, specks of dust. I tried my best to get rid of them by polishing from the outside and tapping it, even vacuuming it to get them to move around. Anyway, so there's like 3 or 4 components on each side here, so I'll just do this one here and the 3-pin device here. A few of these maybe double diodes, you know, just to rectify. We may need to take this transformer off because there's loads of stuff underneath the transformer as well. It's a crazy design. You know, often when you've got something as fiddly to work on this, the exploration can end up revealing the actual faults. May even be able to see something burned and charred on the other side of this once we get this heatsink assembly off. I think that's it. So assuming I've got all of the solder off, let's just have a bit of a pivot on each of these here. Oh, there you go. I was going to say, try and just wobble this one way or the other and not pull it off at some crazy angle. There we go. So yeah, we've got that off, which means we can now test these devices. But I think also the benefit here is flipping this back over if we can. Yeah, we can see under here now. So, you know, there's not much under there, to be fair. But we have got, you know, obviously a couple of caps and a resistor down there, and it's obviously very dusty and dirty. I think the next thing I'll do is just to test these devices here for shorts. So, what have we got? Is that a rectifier? I think it is. Yeah, AC, but it's double diode, isn't it? So, let's just check there. Yeah, no shorts, 2 diodes, that's alright. And then we've got, what's that? Can't see what that is at the moment, let's just test. Yeah, no shorts, that's good. Somewhere around here is the 7805, might be that first one. And maybe an SCR for short circuit protection or something. Yeah, no shorts there. No shorts there. And no shorts there either. So those devices seem okay at the moment. So there could be a reason why, but this 3-pin thing here measures as a short. The interesting thing is it's got this cap bodged onto the resistor there. But if I just flip this up and we measure between the 3 pins here, you'll hear, hang on, yeah, dead short, almost a short, almost a short. It's interesting those two there are dead short. So yeah, like I said, there could be a reason, there could be some connection that goes across that or something in parallel. There's a diode behind it, is that diode short? I don't know, let's just measure that diode. And again, it could be the way it's wired. No, that's got a forward switching voltage that way. The diode behind it again, the other way. That's alright, so the diode's alright. It ain't that. Could be that cap, maybe. Yeah, we're getting the low resistance across there. What size resistor is that? Yeah, brown, black, brown. That shouldn't that be 100 ohms? So is it measuring as, maybe that is right, so let's just try on resistance. Yeah, it's showing about 37 ohms there. So, I don't know, I think the next thing I'm going to do is pull that 3-pin device there off. Maybe that's an SCR. That might be short circuit protection or something. Let's just even get that wire off and go to the middle pin, just for reference. Just bend that up. I'd like to try and test it out of circuit. Yeah, I would always just go off, you know, testing these semiconductors as your next point of call, really, when you're trying to work out an issue like this where it's ticking. There we go. So let's now just measure that on the bench and hope for a short. Well, so be careful what you wish for. Might be able to get a replacement, yeah. Yeah, we've got a very low resistance. That's dead short there, between those two. So I think that's faulty. I think that's the issue. So I think that's going to be an SCR, just a guess. Let me go see if I can find an equivalent or something. Yeah, so trying to piece this together. This is a triac and it's shorted. It's a BTB 16200B. Can't get the 200 volt rated ones anymore anywhere, but I found a 600 volt, so BTB 16600B, I think. So assuming the pinout's the same, I will try and check that if I can. That I think is the fault, but yeah, I was just posting on Discord, I was saying from experience, when you find a short triac, don't just replace it, because you know what, it'll just explode. This is what usually happens. There's usually a cause, a reason that triacs will go. Or it may have killed something else on the board, and I think that's the case, because I was just re-inspecting this tracer before, and let's just measure across it. It's home circuit. There's actually a blast mark. That black thing there, it's blasted open, but you see that's probably blasted open as a result of this MOSFET shorting, and it's had a mod here, not MOSFET, sorry, triac. It's had a mod here. Someone's cut through this trace, but it's got this crusty flux. I'm just wondering if some of this flux has become a wee bit conductive, because I've seen this used on products before where it goes all horrible and browny like that. It starts to pass a bit of current. But I've also seen, you know, the glue and stuff they use start to conduct. 12 volt vids was a guy that I watched that, you know, he mentioned it, and I was like, oh good, it's not just me then, because I had seen the same thing. He often points out that the mastic or silicon that they sometimes use on certain devices, monitors, CRTs, power supplies, it does start to become conductive. It must be some sort of chemical change. It could be when electrolyte leaks from a cap nearby, it reacts with it and changes its, you know, its composition or something like that. And of course electrolyte will cause a problem on its own. But none of the caps on this look like they've leaked. But yeah, anyway, we do have a blast mark there and a gap in that trace, so that's going to need a fix. I'm just going to clean around this to start with, to get rid of this horrible browny stuff. So the underside of this is coming along a little bit. I need more cleaning on the top side, but I'm going to start replacing and testing some of these caps now. So certainly these smaller ones here, we'll get these ones off, and these ones as well, just to test those ones. But these I'm definitely going to swap. The bigger ones you tend to find they're pretty good on these power supplies. But yeah, I may have some replacement for these. 680 microfarad, 200 volts. Pretty big those actually. You often find that these are like 33 microfarad or 68 microfarad. But those are quite large. Anyway, this cap here then, its ground is to the left side here. I can't see its rating at the moment. It's soldered in parallel with that cap, the resistor rather than the cap. So it's an interesting modification. I'm guessing these were done at factory. So it's 105 degrees, 50 volts, 1 microfarad. So connected up to the meter. As I've said in previous videos, it's always worth shorting the contacts on these just to make sure the cap doesn't have any voltage in it. Even though it may only have 50 volts if you're lucky, yeah, that could blow the meter. Yeah, that's showing 10 microfarad. I'm sure it said 1 microfarad. I'll just check that again. And it's only doing 1 ding, so you know what, I would swap that anyway, but it's probably within spec. Yeah, it's a 10. There's just a dot, a bit of dirt on it that made me think it was 1. So we need a 10 microfarad 50 volt. Right, so I found a replacement. It's not ideal. It's I think it's Rubicon or something, but it's brand new, 10 microfarad, 50 volts, and 105 degrees. So if this is better on the ESR, it might not be. Yeah, it's higher. Look, it's higher on the ESR. Let me see if I've got anything else. I don't really want to stick that in. Yeah, I've got some 85 degrees here. It's on the very outside edge of that heatsink, so yeah, listen to that, ding ding. I'd much rather put that in. I'm hoping there are not too many 10s on here because I'm getting really low on caps and I've got literally no decent 10 microfarads. What I really need to do is order an absolute ton of caps at some point to get all my stock levels back up. Yeah, so I've got a decent ESR, 100 microfarad, 25 volts, ground towards the right. Obviously, because it's only single-sided, you don't really need to leave it as long as I just did there. That's just a force of habit from working on double-sided boards. Yeah, so I'll clean the solder points up later, but I will just mark these as I go along, just so I know which ones I've done. I mean, it's blatantly obvious because I've only done 2. It's not hard to forget where you're up to, is it? So I'll get these 2 little ones here off next, I think. So I had a wee tidy up around a few bits here, you know, so the flux has all been removed from lots of areas here. I will toothbrush it later. So I'm now going to focus on some of these awful connections and things. There's that giant connection, wherever that's gone, and somewhere up there. Yeah, huge wire that's been squished against the shielding on the underside. When I say shield, I'm sort of the isolation thing. It's like a brown piece of plastic. And that's not a design thing, no, it can't be. I think that's just crazy manufacturer, to be honest. I mean, these were certainly built to a price point, weren't they? Well, it goes without saying, all the rivets on it evidence that. We'll reflow that one as well, just for good measure. Hang on, there's nothing there. Was there a wire in there? Let's just see. No. Yeah, that's the point where the ground for the what's his name goes, the fan. That explains why it was like that. I reckon that was an aftermarket thing or something. You know, someone's maybe looked at this, they detached that and then soldered it back and just pushed it right through the other side. Anyway, that's that. But there are some awful solder points here. Can you see this switching transistor? That looks like that's been reflowed. So maybe this is what someone did. They took it to pieces, they flowed a few things on there, made a crazy mess of things, tested it, didn't work, went, I don't know what's wrong with it. Anyway, we're going to remove all of that solder and we're going to reflow those. So as you can see, just desoldered the transformer. We've replaced the caps around here. Yeah, so all the ones around there. Got some smaller ones on order. But right now I want to just clean up around the underside there and swap these 2 tiny little caps here. Anyway, it's looking a lot cleaner there. So I mean, whilst I'm here, you know, I'll test these diodes, obviously on diode test on a meter. I'll test any resistors just to, you know, make sure they're not gone home circuit, etc. You'd tell if they were short because they'd probably blasted themselves open. So I've tested all the diodes on here. I'll show you this one here. So red lead is on diode test, red lead on the anode, that's the side without the band. The cathode has got the band, and we can see forward switching voltage. Some of these, when you measure it reversed like this, you'll see something because it's in circuit. That one's not showing anything actually, but yeah, let's try one of these. Yeah, reverse look is showing. Yeah, so that way around, anode to cathode, the correct way, it's showing a forward switching voltage, nothing that way. So I tested all these diodes, tested the transistors between all three legs, all three combinations, to make sure there's no shorts. So none of the transistors are short, the little ones, including that one there, and including the main switching transistor here. We've got a resistance there, but there is a resistor across it. You can actually see it on the board. It's probably like 100 ohm or something. There we go, 100 ohm. That was a good guess. And between the middle pin, the right pin. So yeah, there are no shorts there. So I think, and in fact, the cap I just removed here, this was 100 microfarad, 25 volts. It's showing as bad. It's got like 6.8 ohms resistance, you know, ESR, and its capacitance has dropped to something like 8 microfarad or something from 100 or something like that. I'll show you that in a minute. It might be 33 actually now I think about it, so it's like a third of what it should be. So that's the issue there. Whilst we're here, we'll just have a, you know, a bit of a clean with the toothbrush here, just to get in and around the legs that we can't access once we get the transformer back on, because that's the next thing. So yeah, we'll just carefully, now we've done all that sort of stuff there, carefully get this back into position here. And we've got to be careful because there are more pins here than there are there. Yeah, that's correct actually, yeah, that's alright. Just go like that, and carefully flip it over and solder it back into position. That's it, so that just needs cleaning up now. Just make sure I've got all the solder points on. And again, just have a bit of an inspection diagonally into the gaps there, just to make sure nothing crazy is going on. Yeah, that looks good to me. So this one here, I don't think I'm going to be able to find a replacement for it. It's a crazy voltage, like 100 volts. I'll go and have a look now. It's 100 volts, 22 microfarad. I don't have anything that high voltage, I don't think. And then we've got some 10s down the side here, and obviously these 680, 200 volt ones here. So yeah, I am going to replace them, and then it will have had a full recap. It's going to be a workhorse, this. And I think if I planned ahead, I would have got, you know, Panasonic FRs for every one on there. But I've just gone with what I've got. So some, you know, different brand, super low ESR ones, an RS one, a few Panasonic ones, the odd Nichicon. I think we've got one Forever one back there, and then some of the weird old one I've had for ages that's just got better ESR than the one I took off. Right, so let's use the Atlas Peak semiconductor tester. You can get an equivalent of this, you know, some cheap Chinese jobby off eBay for, I don't know, about 10 quid. So don't assume you've got to go with Atlas Peak. But if you're intending to get into regular repair of these systems, either as a hobby or, you know, to as a business, consider investing in this, in one of these, an Atlas Peak one. They're really, really good. I really like them. Anyway, let's just hit test. So this is the SCR. Short circuit, there we go, on red and green. So you know what, it's given me a bit of confidence there, even though I knew before I used this that this triac has balked, yeah? So that's the fault, I think, the main one. That's the one that blew the trace. We'll do the capacitors after, I'll show you that capacitor, but in the meantime I figure, let's just test these. Now these are riveted, so you'd have to drill these out, I think. I don't think it's like a hex nut. Kinda looks like a hex, but yeah, they're riveted. I'm sure they're riveted. That one isn't, that's bolted on. In any case, we can just test these and see what it says. Yeah, one or two of these are just going to have a couple of diodes in. You know, it's like a double rectifier. I don't know its actual proper name. I can't remember. I'm sure I once knew. Now I can't remember. Anyway, let's just hit the test button there. There you go. LED or diode junctions. So it goes cathode, anode, cathode. What's on red? Forward voltage. Yeah, so that's interesting. Is that a regulator or something? Let me just see what that is, because it's saying there's like one diode in it. That's a 7805. So anyway, the bottom line is there's no shorts. I'm sure that 7805 is alright. And you know what I could do, and I'll do it in a minute, get the bench power supply, connect up the ground and the, I don't know, 9 volts and just measure the output. We'll do that. But I am not going to go to the stress here of removing the rivets, replacing that, just on the off chance, oh, it's an old 7805. They seldom fail when they've got a really good heatsink like that. So again, this one's coming up at LED or diode junctions, and it's showing me some weird connections. It's probably another regular, maybe a 12 volt one. Yeah, it's a 7912 minus 12, that one. The component on the end here is a BDX34B. Is that another SCR or something? I don't know, it could be a transistor. So, let's hit test again. Darlington transistor. There we go, that's a good sign, isn't it? Scroll. It shows us our base collector emitter, diode protecting between collector and emitter, resistor shunt between base and emitter. Isn't that cool? HFE not accurate due to the BE resistor. Current gain 37, test current, base emitter voltage, test current, leakage current. There we go. So isn't that cool? This is the thing. These are really good. On the cheaper ones, you won't get all that information. That's the thing. So like that side, I'm pretty convinced that's alright, but we can test these regulators just with a bench power supply. We know the transistor's alright. Yeah, again, I am not sure what that is. It must be another transistor maybe. And this here is a rectifier, because you can see you've got AC, AC positive. Yeah. So anyway, let's test the smaller one. And this is the thing, you know, you can do all these tests obviously with a multimeter, but this is the thing, with a tool like this, it just saves you so much time. You can really quickly get to the bottom of what's going on with this. Common cathode diode network. Oh, there we go, so it's another one of those diodes. Pin out for D1, red and blue, anode cathode, forward voltage, test current, pin out for D2, so there are 2 diodes. There you go. So we know that that's a rectifier, and that's alright. No shorts there. And we'll do the same with this, and I think this is another rectifier, just the same, but it's a bit beefier, so let's see what this one is. Quite a lot beefier actually. Common cathode diode network, look. Been out for diode 1, so you've got your anode and cathode there. Forward voltage, 0.19, it's like a shock, isn't it? Test current, been out for D2. You'd expect the same between these, yeah, same voltage drop, look. Shocky again, or something similar. Common cathode diode network. There we go, so that's it. Anyway, you've seen that. So, you know what? Other than me testing the voltages on these here, and I'll show you that, I think. I'm confident that everything on there is right. Yeah, that's good. Well, it's good knowledge, isn't it? And when you know you've tested the caps, you see no problems with resistors, your diodes are good, your transistors aren't shorted. Yeah, we'll test these and make sure these big beefy resistors here are alright, because you know what, it's not uncommon in some power supplies and monitors for these to just go open circuit, because they're usually like really low resistors, like 1 ohm or something, which is why the ceramics like this, they absorb, you know, they absorb all that heat, massive amount of heat. You can have high current through them because they're so low resistance, you know. And they can fail, and you can get dry joints on those sometimes on the underside. Coils, you know, we tested those. It's just a short. They're all right. You'd be able to tell because they'd be blown open if there was a problem with that. So all that leaves is the transformer. Yeah, I've got no reason to suspect the transformer being a problem because we heard it making a ticking noise. Yeah, so I think it was just like shutting down. So yeah, comparator stuff. I think that's like a voltage comparator. So we could have an issue here somewhere maybe, but these transistors all measure alright in respect to there are no shorts. Diodes are alright around here. We've got a little IC there, so we need to perhaps check that and that if we had a problem. They could be optos, those, just thinking about things. If we have a look at where they are, yeah, look, it's in between this connection's here and the connection's there. This one, you know, there's a gap here. Yeah, this is your air gap kind of thing. It's not really an air gap, but it's a gap in the traces, isn't it? Some power supplies, you see, will have an actual air gap where the PCB is cut out. We don't have that. And they might even be over the top of the air gap. So it's not an actual air gap, but it's a gap, in, you know, quite a wide gap in terms of potential path of current, you know, from one side to the other. You know, the more distance you've got, it's harder for something to short across, isn't it? And we know we got no shorts here. The resistors and things look good around here. I haven't tested that bridge, but you know what? If that bridge had shorted, the fuse would blow. This is the thing. So you can just assume, make lots of assumptions. If you see your fuse is right and you hear it ticking, you know the stuff on this side, the primary side here, is probably all right. There's a chance it's maybe not switching at the right frequency or cutting off due to a fault somewhere, but the bottom line is you can assume various things based on, you know, behaviour. And it's the same with these caps. So if these caps were an issue here, it would be popping fuses. You know, if these are short, gone high ESR or something, you'd be popping fuses, but we will replace those anyway. So yeah, I feel comfortable now. I'm just going to test the voltages on those two regulators, and then we'll get that whole heatsink thing back into that. Yeah, hopefully you can see the meter there. So if I probe that right hand pin, try and switch the bench power supply on. There you go, minus 5.8. Switch it off. That's good. So yeah, we'll do the same thing with the 7912. That's a you know, a 12 volt regulator. So I've got it set to minus 18 volts. Switch it on. Minus 12.6. And of course you could just hover for a minute, just check temperature. Again, current controlled here, current limited to like 300 or 400 milliamps. So yeah, it's not going to race away and go crazy and burn itself out if there was a problem there, but yeah, minus 12.64 volts. And that's using the Agilent here, but many bench power supplies work the same way. We've got you know, a 5 volt rail here, ground and positive, so you can have a, you know, positive voltage up to, I think that's up to 6 volts actually, and then you've got an earth connection. Yeah, that's useful if you want to earth something. It goes through to the earth connection obviously on the mains lead that goes in, and then you've got positive and negative here on the 25 volt rail. So, and there's a separate button to, you know, if you want to use the positive up to 25 volts, you press that one. If you want to do a negative one, you press that one. We've used the negative rail, which means we, you know, got common ground there, and this is then marked negative. So this is where the negative 18 volts, or in the case of the 7905, I was feeding like negative 9 volts in. And that's what you need. You need, you know, a voltage higher than the voltage it's regulating down to. So yeah, that should be right. On the actual power supply itself, that's the feed into the 12 volts. It might not be minus 18. It could be minus 25 or something like that, or minus 20. I've got no idea. And it did take me a minute or two of messing around, straightening the legs there in order to get all of those legs through. So yeah, it's a bit like the transformer, kind of like hold out, solder one a point or two, maybe on opposite sides. Just inspect to make sure no pins just slipped through. Yeah, and all the pins are still in position, and do exactly the same thing. Solder a point up here maybe, and then press down again whilst you heat. So just for the moment I've had to put its original cap back on there. The cap is alright, CSR is good, its capacitance range is good. The problem was, you can see how close it is to the heatsink here. It was like pushing the cap right down to here because it's quite a long axial cap there. So I'm just going to use the original piece of hot melt glue here, and you can see roughly where it was wedged in down here, like that approximately, and I'm just going to heat that. Yeah, it's on the heatsink. That's all we need. It's just to make a little bit of mechanical connection there to stop vibration, I think, more than anything. So I'll just let that cool. Yeah, so I scratched the blackness off here and on the edge there, because it's almost touching that trace, because it goes carbonized, you know, it becomes conductive. I'm going to just use a piece of kynar because it's nice and thin. We don't need a lot of current to be passed across that trace, I think. So I think the kynar will be fine. Obviously the proof is going to be in the pudding, you know, in terms of testing for a period of time. But what I don't want to do is use really, really thick wire, because it's kind of a safety feature, the thickness of that trace, in the sense that if the SCR goes, the thing that fails next is that trace. So if you make it too thick, the wire here, then it could fail elsewhere. Do you know what I mean? You keep, you know, if you keep that ridiculously high current working, you know, able to get from one place to another, yeah, then you get a problem. Let's now just trim. I'm just going to just bend it into position, flatten it down, and just solder it there. It may come loose at this point. So it's still kind of going to be fusible because of how thin it is. Right, so the next thing you're going to do is clean out this fan here. Ugh, look at that. I managed to just bend the cotton bud a little bit and then it'll, tilt inwards. Right, I'm still waiting for these caps, but I've got some Panasonic 10 microfarads, so I can replace that dodgy one there and the ones on the left hand side here. So yeah, I think this is the same family as the one that was on there, so BTB16-600. So I think the difference is it will handle a lot more power, but it's 16 amp, isn't it? So the other one was rated to 200 volts, this one's rated to 600 volts. So I don't really see that being any kind of problem in this scenario here. It's probably just like shunting, applying a short somewhere in some failure scenario. So the 16 amp thing is the same, but it could, handle higher voltage. Well, we're not going to have a higher voltage, and I'll bet that's probably not on the main side anyway. It could be, I don't know what voltage is going to be going through that, to be honest. I don't know which side it's on. It probably is on the primary, actually, looking at it. Although I don't know, it's a bit weirdly laid out, this board, because you've got the switching stuff here and the caps and things, but then you've got a transformer, and then you've got the optos down here, so it's like, I don't know, it's anybody's guess as to which side that's on. It's probably going to be on the primary, I want to say. I could be wrong. Post your comments down below if you know. There we go, that's going to make a pretty reliable connection, I think. So I just need to just clean around that and inspect for any shorts. Let's now get a new 10 microfarad cap back across there with its ground to the left. Yeah, that's it. And then aside from that one, which I don't think I'm going to swap, I might see if I can find a high enough voltage rated cap on eBay. And those two which I have ordered that aren't here yet, we can test it at that point, and I will do. I think we'll give it a try. We'll do the final clean-up later with a toothbrush, but I just want to just clean around, inspect, and then we'll loosely reassemble it, screw in with one screw or something. I'll get a mains lead, I'll make sure the fuse is set to, the fuse is like 3 amp or something like that. We don't need 13 amp fuse, certainly not. I don't want to start a fire, just in case something does go wrong. In case I've made a mistake, this is the thing, don't just assume you may have the original fault. You may have some new one that you've introduced if you've not been careful. Particle solder somewhere, something joined up where it shouldn't be. Something fitted the wrong way. Even the equivalent, this Triac, I haven't been able to find a data sheet for the original one. I'm thinking, is the pin out the same? Well, it'd be crazy if it was the same family of component and had a different pin out. And I guess I should now check for shorts actually around that Triac, just to see how that circuit measures now the new Triac is in there. Like, is it different from the way it was before, where we had a couple of pins directly shorted on it? So let's just carefully try and work out how this goes back in there. It goes that way, doesn't it? So let's move the connector out of the way. Just check all these wires. So I'm going to check back the footage to see which connections go here, the live and the neutral. I think it was the top ones, but got to get them the right way around, obviously. And this is going to be the tappings into here, I think. Well, it's taking a strange convoluted route, isn't it? To determine whether you got 110 volts or 220 volts. Well, we aren't actually using either. We've got 240 volts here, 235-ish maybe. And I guess it highlights that if you pick up one of these power supplies off eBay and there's no clues as to whether it came from, a UK machine, you might want to go and check how those jumpers are wired up and stuff before you try it, because you could get a US one, from a machine that's been bought in the US, broken up for parts or stuff, and the power supply sold on, and you have no clues, do you? Unless there's some marking somewhere to say. I think this one does. I think on the white print that's gone all blurred there, I think it says 220 220 volts, 240 volts, something like that. Just the print on it's so blurry I can't see it. So you know what, I think actually I would do that myself on market. Once, if we get this working and we clean up the rest of the board, swap these caps, I'll stick a label on it to say when it's been serviced, but also say 220 volts so that it's obvious. I'm just going to put one screw here and then just go away now and work out which one of those go where. Yeah, they're not very good, those connectors, you know. I'm just going to crimp that marginally here. Just squeeze, because that just feels so loose. Yeah, that's well crimped now. Yeah, that's not too bad now. What we'll do when I take this back out to clean the underneath is just clean those spade contacts with a fiberglass brush as well as just tightening them both just a little bit. Well, not the both, the blue one certainly. Right, so place your bets. Do you think we're going to get a bang? I hope not. We could do that, because I've not tested every single thing on this. There could be some sort of fault in one of the two or three ICs on there. So I've got mains lead here, so it's just, that's on, that's off. Plug the power in. Are you ready for this? I am going to hold the mains lead and switch it on this way. Ooh. We have life, I think. Oh yes. Sweet. Yeah, fan is nice and clean there. I spent hours cleaning that. So, it's a bit noisy. Needs a bit of lubrication or something, or replacement. And yeah, as I say, the rivets, all the rivets, you could just drill. Get a drill as wide as that maybe, and just drill into that. And then you could replace the, you know, with screws and stuff. Fantastic. So let's now measure the voltages here. You know, there could be an issue here, despite the fact it's got new caps. We've resolved the problem, you know, the immediate problem with it. What we don't know is if those optos, one of those optos is a bit balked, it could be overcompensating. You know, your LED starts to dim a little bit because it's coming to the end of its life. Then that affects the, you know, the can affect the regulation side, and it can start to, you know, drift. You can have a slightly higher 5-volt level, a lower 5-volt level, or whatever. Yeah, that's the grounds are the blues on these, aren't they? Yellows are 5 volts. There you go, 5.38 volts. That's with no load. Let's now test the other wires here. So orange is that 12. Yeah, so the 12 is a bit low, but you often find this on these. It's around the 11 volts mark. The red, minus 12. Green, that's the use of 5 volts, isn't it? So that one's spot on 5 volts. White, one of these is tick, minus 5 volts. I didn't know there was a minus 5 volts on these. That's interesting to me. I mean, there is on the 4000, and then I think brown's tick. Yeah, so we're seeing an average there. Look, 2.4 volts. So that's you know, if you look at it on the scope now, let's just check that. That's going to be 50 hertz sine or 50 hertz pulse. I don't know which. But we're seeing the, you know, the median, the average of that, because it's swinging. Yeah, you know, it's like peaks, PWM, you know, you've got 50% duty cycle. Interesting point with scopes. If you're wanting to scope something in a power supply, make sure you've got isolation on your, you know, an isolation transformer, because some things are referenced to earth and others not and stuff, and you can blow your scope up if you're not careful. But in terms of this, we're dealing with the output side that's isolated by the transformer. So in theory, you know, if we just connect, probably don't even need the ground, to be honest. If we just scope the pin there, and if you look at the frequency there, I'll put a highlight next to it, 50 hertz. Yeah, so it's kind of like I don't know, it's not really a sine wave, is it? But that might look more sine-like if I had a ground connector, but I'm not going to do that. So I would suggest the next thing to do is just switch it off. Would be to do what we did at the start. So I'll get those wire wound resistors, we'll connect them up to the 5 volts, we'll just draw half an amp. Yeah, they're in series, these two 4.7 ohm resistors in series between ground and 5 volts. I could put the meter in series with that, and then we can measure the current. I may do that in a minute. Anyway, let's just make sure everything's okay on the bench here. Let's just switch it on. Interesting thing, can you hear the fan going faster? That's a bit concerning. Maybe that it's now got load, now the 12 volts is right. I'm more inclined to think, those are getting warm, yeah? I'm more inclined to think that these need a bit of load in order to output all of the right voltage levels. So we may now find that the 5 is a bit more balanced, like nearer to 5. We'll test on this thing here, actually. Let's just test on here, because I've got 5 and 12 on here. So the 5 is now 507, look, with a bit of load. We can hear the fan is faster, that tells me the 12 volts is probably nearer 12. Look at that, 12.2. So that's the thing, so if you test one of these without any load, the fan's going to sound quieter. I can show you that, switch it off. These are going to be warm now, I think. Oh yeah, nice and warm, because it's been drawing half an amp. Let's just pull those out, switch it back on, listen to the fan. Hear that? Nowhere near as fast. Sounds like 20%, you know, or so slower. And that's just as a result of it'll be going, you know, on the 12 volt rail certainly, and I think on the 5 volt as well probably, it's like switching on, off, on, off, on, off, on, off, so you're not getting quite the right 12 volt level. We're seeing slightly higher 5 point, you know, we're saying 5.3-ish, 3.5, weren't we, on the 5 volt rail, but then when you get a bit of load on there, then everything balances out. Make sure I've got that in the right connections. Hey! Wind tunnel mode. Right, many capacitors have arrived. You can see they are way smaller. The spacing could be, and probably will be, completely wrong here. You know, if the cap points are like quite wide apart, those aren't going to fit. So I may need to do a modification. But I'll be honest, I kind of want smaller caps like that. It's going to be less heat problems and things, isn't there? They're about the same height, I think, if you look at those. Yeah, they are. But anyway, they're way narrower. So this is one of the old ones. We'll do the other one in a minute. And this is the thing, ding ding, really good ESR, good capacitance, should be 680. It's just right there, isn't it? And we'll check the other one as well. And these weigh a lot. You know, when they lose the electrolyte, they'll be quite light. But these are really heavy capacitors. And again, low ESR, good capacitance, look. So yeah, those will go into the Armageddon supply bag. And despite the fact you've just seen both of the new caps on, this is the one, yeah, I'm about to fit. But you've already seen it already fitted, just to confuse matters. And you can see the ESR is marginally higher, yeah, capacitance about the same. So this is the thing, are these caps any better than the other ones? I don't think so, they weigh about the same. I did just clean underneath that capacitor and around the extended area while the cap was off there actually. The first one, it looked alright underneath, but yeah, it's always a good idea to clean underneath, things like that, just in case any electrolyte has leaked out. I managed to use that screwdriver actually, I just managed to just lean it this way a little bit and I managed to get it in. It was a bit tight and it was a bit hard to get that final screw in. And then obviously just push the power switch back into position there. So let's get, hang on, cable ties. There were a few things cable tied in there. Yeah, they're not going anywhere, are they? There's nothing else really to worry about cable tying. I guess these may have been cable tied here. But yeah, that'll do. So let's get the lid back on, and it obviously overlaps on the outside all around. This heatsink is clean, you know, but you can see there's some brown marks on there that's not coming off. But anyway, I'm going to stick the label here. The interesting thing as well, and I didn't point it out, says there manufactured date 20th of January 88. There we go. Repaired, recapped 2023. And we stick our little magical red dot. And because I get to assemble it a second time, I can get the screw with the red paint here lined up with the point there, look. there you go. Looks like no one's been in it now. Yeah, and I'm sure there's nothing missing from that. Switch it on, let's see if it works. Oh, something blue. Well, I'm quite puzzled and a bit disappointed because obviously the fuse is blown there. Let's just try and get that out. Breaking. Yeah, you can see that is completely toast. Did I get those wires round the wrong way here? I thought it was like that one and that one. Maybe I got the blue and the black the wrong way around. I need to go check that. Yeah, I'm not sure what just happened. I don't understand what caused that. So we may have some sort of secondary fault. It was empty blue, empty black. Was that how I just had it wired? I'm sure I did. It's like miss one blue, miss one black. Looking at it, you know, the other way around. So anyway, we've replaced that fuse. I've had a measure around on the primary side. I can't see any shorts, can't measure any shorts. There's nothing on the capacitors, on the bridge, on the switching transistor. So let's just make sure it's off. That's on, that's off. Let's plug the mains cable in. I'm assuming the fuse is alright on this. Switch it on again. Not working. So has that fuse blown? It's going to be really annoying if there's going to be another fault with this. It might be part 2 to this video. Let's just check that fuse. And of course, maybe something's gone on with the transformer. I don't know, that's a possibility. Yeah, the fuse is blown again. You know what I'm thinking? I'm thinking one of these new caps has caused me a problem here. Actually, I might get these back on it. So let's try it again. I've got its original caps back in, another fuse, double checked everything again. I can't work out what is going on here. This makes no sense at all. Even like the varistas and things on there. So, power. Nope, fuse is blown again. Right, take this as a lesson that when you get stressed, stop, inspect what you're doing, and have a think about the most logical things. Now, the thing with panicking here, this is me through and through. When I get stressed about something, I immediately go from 0 miles an hour to 1,000 miles an hour, break all speed limits, and start to make more problems for myself and not realise something really obvious. Spot anything? I'll just leave you for a second there. Spot anything obvious at all? Anything? See anything? Like the grounds on these, I said towards the centre of the board, and then I fitted them with the outside towards the outside of the board. I think that's what the issue is. I don't think it's destroyed anything. It won't be good for the caps, but you know what? It happens in such a short period of time that these probably just short, and that's it, bang, fuse goes. Yeah. So I measured the other ones. The caps measure all right. There's nothing wrong with them. I don't think it won't have done them any good. But nevertheless, I've done the same thing with these ones. So let's just now take these off, put the other ones back on. Hope I haven't completely destroyed this, and just learn from my mistakes here. This is a stupid mistake. It really is. I've just checked. There's no voltage in these. So here we are, swapping them a second time. I think I've got one 2 amp fuse left, so wish me good luck. Right, so yeah, I think the one that was on there was a T, Trage, you know. This one's an F, first blow, so I don't know, it might blow even faster. Because that's the thing, I think a Trage fuse, a T, is timed, so it gives it a little bit of inrush allowance, if you like, I think. Anyway, so it may blow again, so it's miss one blue. And then miss one black. So I definitely haven't got these around the wrong way at any point, you know, and that was one of the reasons I went looking at the video footage there, because, you know, and this is the thing, can you see we've got an AC signal there on the one we're not using, and an AC signal there on the one we're not using, a wiggly line. Whether that means don't use this, I don't know, or whether it was originally a 110 volt configured unit and then someone switched it over, I honestly do not know. Hang on, let's get a screw in before, because that board is kind of floating around a bit, isn't it? I'll just get one screw holding this corner here. want an earth point as well. That's the other thing, that mounts with earth, I think, that one. And that was something else I checked. Do we have a short between live, neutral and earth? Because you may think, you know, because you've got to think about what else have we done? Well, we screwed the board in. Was there something else? Is there something that's leaking to earth? Anyway, it's off. Just checking, I've got this running. Yeah, and I'm double checking here. Miss one blue, miss one black. Fuses in. Caps negative towards the centre of the board. Let's plug it in. What do you reckon? Switch it on. It's working again. That's what it was. That's what it was. Those caps were shorting in a very short period of time. And they weren't warm. It's because it's so quick. I think I've just looked out. But yeah, reliability of those caps. If I was selling this now, I'd be a bit nervous, if I'm honest. But it's going to be a bench power supply. Anyway, there you go. Sometimes it's good when mistakes happen because you can learn from my mistakes. In terms of calculating current there, there's a pyramid. There's two of these actually. There's one for power and current and wattage and stuff. But anyway, the one for voltage and current and resistance is V, I, R, V. Yeah. The line in the middle means multiply, the V means divide. So you can work out any of the third components there by having the other two. So we want to work out, if we want to draw 1 amp, yeah, you take the voltage is in volts, 5 volts, resistance, if we use a 5 ohm, yeah, voltage divided by resistance gives you the current. So 5 divided by 5, that's going to give us 1. Yeah, 5 divided by 5 equals 1. Yeah, so that's an easy one, because if you know it's 5 volts and you use 5 ohms, you can easily calculate, you know, it's going to be 1 amp. If you want to draw half an amp, yeah, it just stands to reason you want to double the resistance or the voltage here. So we don't want to double the voltage, we've got 5 volts, but if we double the resistance to 10 ohms, it's 5 divided by 10, that's going to give you 0.5. Yeah, so yeah, it's really simple. And as I say, if you know 2 of any of the 3 components there, you can work out the third one. And the 2 resistors obviously aren't exactly 5 ohms, they're 4.7. I've just rounded it up to do the math easy in the head, to work out that, yeah, I need 10 ohms roughly to get roughly half an amp. I'm not sure I showed the capacitance here. This one you could see the bung was hanging out of it. Yeah, I think that may have been cut in the edit. So that was one of the caps, and then the other one is the one that I think was 33 microfarads instead of 100. It's probably showing about 8 ohms or something. There you go, look. 8.7 ohms, and it's only showing a third of its capacitance rating. So, all tidied up here now, 40 minutes later. It's been on while I've been cleaning and vacuuming in here and throwing out the 100 cotton buds that I used on this board. Yeah, and the resistors there, yeah, nice and warm, not hot. You can see 12 volts is nice and healthy, 12.22. Yeah, I thought the 5 volts was struggling there. I think I just got a bad connection. It was going like 2 volts, 3 volts, 4 volts. Yeah, 5.8. Now the interesting thing on a power supply like this, and why you might want something more modern, either a more modern revision of the power supply in general, because the later machines would have had a better power supply probably. Maybe not, maybe a cheaper one. But maybe something like, you know, doing a mod to fit, what I'm going to do with the other one in a minute, the can I'm going to show you, fit somewhat more modern power supply inside the can here. Switch this on, just watch, you'll get, it'll overshoot 5.4, 5.3, 5.1. So yeah, I mean, it doesn't go any higher than 5.3, 5.4-ish, but you do get that peak right at the start, and you get that on some cheap bench power supplies. I'm not sure if I just knocked something there. It's probably the wires, yeah, it's just the wires. And you know what, without an extension, it's quite difficult to position this. I've had to use some ESD safe bubble wrap under here just to isolate the ISA slots and the Zorro slots. And then of course you can't fit Zorro cards, so yeah, it's really difficult, isn't it? You could put it around the back if your bench is big enough, but you know, even still, look, it's going to overlap there. So yeah, it's not really even useful to me for testing things like this, so I may just keep this as a spare. Anyway, seems to be working. All booted from floppy and it's working. I did just double check the power connector pin out on here to make sure I had that the right way around. You can technically get it the other way on these. This is what I don't like about the 2000, well, these early ones anyway, the 2000 power connectors for the floppy drives, the Molex there. But yellow is 5 volts, and as I sort of showed in a previous video where I blew one of those drives to pieces, brown is 5 volts. Anyway, I'm going to leave this doing a memory test, I think. maybe for an hour or something, and just make sure that that's stable and doesn't reset itself, because if it does reset and I go away, come back in an hour and find it, you know, it'll be at the menu, it won't have gone into a memory test. So it's a nice way to just leave it going around like that. And there we go, about, I don't know, 30 or 40 minutes later, and the memory test's still going, and it's working fine. Yeah, so with that flash incident there, towards the end, I was lucky, really. Yeah, so learn from my mistakes. So yeah, it was the Triac, the trace had blown, and then we had, obviously, 2 capacitors that were bad. Both 100 microfarads, incidentally, the same brand as well. And I did say I was going to show you that other shell, so here's the other shell. It's a little bit rusty on top there, but it looks like it's the same model and stuff. It's got the grommet floating around inside. The fan on this one is screwed in, look, and it's identical. It's got the same power switch and everything there. Glad it's got that. So yeah, at some point I'll get a modern power supply into this, and I think it will probably make it dual purpose. I'll run some cables out of the grommet there, and I'll have 2 different types of connectors. I'll have one for the 2000 like that one, and one for an Amiga 1000, because I'm making or building a replica Amiga 1000 board actually. So yeah, anyway, that'll be another future video. So I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.